And you get 3. Excellent. And then over here, if you do 27 and you hit your exponent button and then you 1 divided by 3 and then you hit equals and you get 3. And then over here, you do 625 and you hit the exponent button and then you do bracket and then you do 1 divided by 4 and then you do bracket and then you do equals and you get 5. So then you say to yourself, self, this 1/2 is an exponent. And you say to yourself, self, there is a relationship that is based in exponents between 3 and 9. What is it? 3 squared is 9, right? 3 squared equals 9, yes? Now, by definition, if 3 squared equals 9, then what does the root of 9 equal? 3, because 3 squared is 9, yes? Now, you being the intelligent young people that you are, you just found out that 9 to the 1/2 also equals 3. So what does that tell you about that? That they too are equal. Right? Because that's how logic works. If this equals this and this equals that, then this and that are the same thing. Right? Everybody follows me, yes? Okay. So then you all have to remember that this symbol right here means something. It means you're going to be seeking a group of factors, yes? Now, usually when we write that, we mean square root, we seek 2 factors, yes? But you all remember there's a little number that lives right there, right? That little number tells you the group of factors you seek. And I've written it in red because I did this in red, because 27 to the 1/3 equals 3. 3 cubed equals 27, which means the cubed root of 27 equals 3. So what does that tell us about that and that? That they are the same thing. So you all now, you also know that if I have anything in there, it too has an exponent, doesn't it? What is the exponent there that I don't write? 1. So all of you should be seeing that this 9 right here should have a 1, shouldn't it? And this little number out here should have a 2, shouldn't it? And this 27 should have a 1. And this 3 has a 3. So all of you should be able to put together something that you already know, that x to the m over n equals the n root of x to the m power. Put that in terms that we've been talking about all the way along. The base right here becomes, this word right here is a new word. Well, new word this year. Becomes the radicand. And that's all you do. Now, I haven't reminded you about how we deal with roots properly. You all already know, but I haven't reminded you yet. You can see my next tab up here is radicals. So that's what we'll be doing next. But on this page, and for this bit here, all of the radicands you'll be able to do in your head. They're not complicated, because I'm trying to get this relationship into your heads. All right? So I don't want to waste time with this being weird numbers. Everybody good? All right. So let's have a look at this one. Now, that being said, I've made the first one very, very difficult. Right? Because if you can figure out that first one, you'll be able to do the rest in your sleep. Right? So, in this very first one, do I have a base? I know the screen just went blue, but do I have a base? It is 0.04, yes? Now, you're all well aware of how I feel about decimals. So what are we going to do with that 0.04? And what is it? 4 over 100, right? So all of you, while we wait for my machine to hook itself back up, we're going to make that 4 over 100, yes? And that 4 over 100 is to the exponent of 3 halves, right? Now, just like we wrote right above, x to the m over n, you know where the n goes, and you know where the m goes. So apply that to what we are doing right now. Hopefully, my screen will turn back on in a moment. If it doesn't turn back on before I run out of breath, I'm going to pull the screen up and do this old school. All right. That was grade 10. Don't worry about that. Oh, I'm a little busy. Okay. So we had 400 to the 3 halves. The 2 comes out here. The base becomes the radicand, and then the whole thing goes to the 3rd power. What is the square root of 4? 2. What is the square root of 100? 10. Yeah? Yeah. And then all of that goes to the 3rd power. What do we know about exponents? Where does that 3 go? To both. So I get 8 over 1,000. Or, since you guys hate fractions, 0.008.
Question.
Answer.
So we're not doing the 9 to the power bracket 1 divided by 2, like what we did in the first section?
No, I only use that to show you why it works.
Oh, it's so easy.
I know it's easy.
So can I use it though?
I couldn't care less. You do what you need to do.
But will it come
But I will, of course, mark it the way I want it marked.
Will it be right?
No,
Oh, so it's not the way to do it?
it's a way to do it.
Oh, okay. So I can do it.
So this was everything I just said. 4 over 100 to the 3 halves, which is the square root of 4 over 100 cubed, which is 2 over 10 cubed, which is 8 over 1,000, which is 0.008. Which 2? Oh, well, good point. We never write that 2. It's like the exponent of 1. Of course not. As a matter of fact, when I do the work, I often write it to remind myself, even me. All right, so let's look at this one. Now, you can do the really hard one, so all the rest of these do in your sleep, right? Where does the 3 go? Cube root of 27 to what power? 4th. What is the cube root of 27? You have asked a very pertinent question, Bea. We will come to that in one moment. All right. So, what is the cube root of 27? 3 to the 4th power, which is 3 times 3, which is 9. And then 3 times 3 again, which is 9. And 9 times 9 is 81. So this answer is 81. All right? Everybody cool? Yeah? Now, Bea said, does the 4 have to go outside the brackets? When this is perfect, like a cube root of 27 equals 3, we usually like to put the 4 outside the brackets, because then just 3 to the 4th we can do often in our heads, right? Sometimes it's not perfect, and then you want to leave it under. And we'll get to some of them, especially when we get into the radicals unit. But for now, we're gonna keep it ones that we can work with in our heads, so we can start getting the relationship more so than the nitty gritty of it. Good? All right. So, oh barf. There's two things you could do here. What is one thing one could do here? Pardon? Never! Decimals! You're evil! Sophia? Yes. You're on the right track.
I don't know what it's called, but
You're on the right track. Yeah, you could multiply right here because those are just exponents, aren't they? And that would give us 8 to the 2/3. Yes, I'm going to change color there because I'm going to do two different tracks here. You could go 8 to the 2/3 because you know your exponent laws and you multiply those, yes? Even though they are they're fractions, an exponent law is an exponent law, right? You got to follow the rules. So everybody cool here? And then, of course, you would do what we just did. You would find the cubed root of what? 8, and then you would square it. Now, again, this is what Bea was talking about earlier. 8 has a cubed root, so we can just leave it, right? What is the cubed root of 8? 2. So this will become 2 squared, which will become 4. Right? Everybody cool? Now, the other way you could look at this, if you wanted to, and I'll do this one in orange. You could say, well, isn't this right here just the cube root of 8? Those are the same thing, yes? And then you could square it, and you would get 2 squared, and you would still have 4. Right? If this one works out perfectly, go ahead and leave it perfectly. But if it doesn't, you'll want to remember your exponent laws. Yeah? All right. What's happening in a letter D? Or as your elementary school teacher always would say, number D. At least mine always did. Because you'd be talking about math. That never happened to any of you? Oh, good. So what should we do with D? D is putting together everything we have done so far. It is a lot like A. Again, I start the row with a very difficult one. I would turn it into a fraction. 49 over 100 to the 1/2. And that, of course, is the square root of 49 over 100. Do I even need the 1? No. So what is it? 7 over 10 or 0.7. Now, all of you should be saying, as always, when we get to these, I just want to use decimals. Just let me use decimals. Here's the reason why you can't just use decimals. That is the same as the square root of 0.49, right? Which gave me 0.7, yes? Okay. What is the square root of 0.049? Decimals are so easy. What's the square root? Now, you know I'm trying to fool you here, so nobody is wanting to say a number. But if I didn't try to fool you, somebody would have said it was 0.07. But that is not the case. What is the square root of 0.0049? No. I know you're confused, but decimals are easy, Bea. Why don't we just use decimals, Mr. Myers? Well, as you can see, they're so simple. This is wrong. What's this? This one is 0.07. Why? Decimals are so easy. Or this, for example, 4.9. What's that square root? You want to say it's 7 somehow, don't you? But it's not. So they're all totally different. This 0.049 square root is 49 over 1,000. Does 1,000 have a square root? No. So this is irrational. But I told you that 0.0049 worked, right? Because that is 49 over 10,000. Does 10,000 have a square root? Does 10,000 have a square root? What is it? It's 100. So that's 49 over 100, or 7 over 100, which would be 0.07. Okay, so once again, I remind you, fractions are actually the easier thing to work with. And of course, this is my favorite. I do all this, and then I ask a kid what the square root of 4.9 is. And they're like, well, it's got to be 7 something. Well, no, isn't 4.9 like 5? So it has to be a little bit more than 2, doesn't it? And yet some kid will always say 7 something there. Of course I'm not going to ask you that, because I've just given myself away now. All right, so now you really got to think. Oh no, a decimal. But you know how to deal with that. What is that? That is, you could think of it as 15 over 10, yes? Would you ever write that fraction as 15 over 10? No, Mrs. Bagcrumble would kill you. What would she make you write it as? 3 over 2. So this becomes 16 to the 3 over 2. And of course, you know what to do with that. That becomes the square root of 16. And in my head, I say to myself, I know the square root of 16, so I'm going to leave it whole, and I'm going to put the 3 out there. What is the square root of 16? 4. Cubed. 4 times 4 times 4. 64. So, you should all be able to do F by yourself now. It is 81 to what fraction? 75 over 100, which we would never write. 3/4. So that is the 4th root of 81 cubed. We already know the 4th root of 81 because we did letter B. What is the 4th root of 81? Letter B. 3, and then 3 cubed is 27. Yeah?
I was just saying the final answer.
I know you were just saying the final answer, Sophia. That's why I'm not giving you a hard time. Yet I notice you jumping to your own defense. I wasn't going to say a word, but listen to you. I got the right answer, Mr. Myers. The right answer, Mr. Myers.
Exactly.
All right. Now, what happens here? I'm telling you to use a calculator right now, right? I'm telling you. Because we know this isn't going to work. Why do we know it's not going to work? Well, because we know that this is the 5th root of 8 squared. Does 8 have a 5th root?
No.
Does it? What's the biggest root 8 has? A 3rd, a cube root, right? Which is 2. No, Sophia, you were right. It is 2. Cube root of 8 is 2. It doesn't have a 5th root, does it? So here is where, if we were not going to use our calculator, we would do what Bea was talking about earlier. Because this doesn't have a 5th root, so we would bring this 2 in here. Everybody cool? So I would need the 5th root of 8 squared, which would be the 5th root of 64. And then, if we were doing our radicals unit, we would break that down. Everybody cool? Now, of course, 64 is 2 to the 6th, and then we would take out a group of 5. But I'm going to remind you how to do that in the next unit. The point I want to make here is because we cannot do this This is irrational. We, next unit, would move this under here and then work with it.
You don't want us to go to the decimal?
You first. Why did I make that 2 to the 6th? Because that's what we're going to do next unit. I'm going to remind you about that. You did that in grade 10. You would end it, if I wasn't letting you use a calculator, you would end it either here or here. I would accept both because they're the same thing. All right? Now, I did say to use a calculator here. So, Sophia, when I tell you to use a calculator, you can go ahead and do the decimals. How would you punch that into your calculator? 8 exponent, whatever your exponent button is. It is not the button that says EXP, so don't hit that. Bracket 2 divided by 5, close brackets equals. And you'll get whatever the answer is. It's like 0.16 or something. I can't remember exactly what it is. It's just like we did at the beginning, but it doesn't work out perfectly. So what is it? Oh, it's 2.2. So, maybe the next one's 0.16. I can't remember. 2.3, great. Everybody cool?
Yes.
If it doesn't work perfectly in there, you're going to use your calculator for this unit. Next unit, we're going to deal with this properly. All right? Okay. So let's look at this next unit. Barf, yes? That would be the 7th root of 6 over 10 to the 15th. Ugh. That doesn't work, does it? So for this unit, we're going to use our calculator. And we would go 0.6 exponent button bracket 15 divided by 7 close brackets equals. Next unit, I'll show you how to deal with that properly. The way all your future teachers, except your future physics teachers, will want it dealt with. Okay? Because physics has no problem with these gross decimals. Math doesn't like it. Okay? Now you talk to a physics teacher, they're like, oh, math, so stupid. Learn the physics. Talk to a math teacher, oh, physics, so stupid. Learn the math. Whatever. Everybody cool? All right.
That's not 46.5, right?
Huh? The answer, 0.6 exponent. Oh, that was 0.6. I didn't get the point.
Yeah, me neither. There we go. That's what wrong. Okay.
Oh, we're good? I don't need to show you?
No, we're good. Don't worry.
All right, good. Anyways. It's all calculator work, right? Or is it? Let's check this first one. You can read the sentence. I don't need to read it to you. A dog with a mass of 27. Where does that number go in the equation? M. M equals 27. Then all we do is fill it in. So the brain equals 0.01 times 27 to the 2/3. Is this one that we can do in our heads? Yeah, of course it is, because we know that's going to be 0.01 times the cubed root of 27 squared, right? What is the cubed root of 27? 3. What's 3 squared? 9, right? Times 0.01. So the decimal's got to move 2 places, right? So it becomes 0.09. That's our answer. Because this works out perfectly, so we can just go ahead and do it. Right? Will the polar bear work out perfectly? Why not? 200 doesn't have a cubed root, does it? So we'd have to use the calculator for B. Does C work if you weigh 60 kilograms, which is 128 pounds? So nobody sitting at the front of the room, that's for sure. That means me. I haven't been 128 pounds since I was like 9. So, huh? Well, that's one word for it. I said I was fat. But, in the 21st century, no one would ever tell a 9-year-old that because, that would crush them forever. But, like that guy who's had to go to court so he could put his kids on the bus. Did you guys hear about that guy? He's got 3 kids. He's a single dad. He's got 3 kids. They range from 11 down to 6 or something. But they all go to the same school. 1 bus ride away. Vancouver has no school buses. So he walks his kids to the bus stop. He watches them get on the city bus and has taught them how to ride the bus. Tells his 11-year-old, when you see your school, pull the yellow cord. Get off bus, walk to school. He is in trouble. He is in trouble. The Ministry of Children and Families has said he is neglecting his kids. They are threatening to take them away. If you look up this guy on Facebook and read all the comments, which you shouldn't do because you, of course, know that 90% of the people commenting on Facebook, I'll just keep my opinion of their IQs to myself, but 90% of the comments are, this guy should be jailed. When I was 11, yeah, damn it, I should have said that. I already thought it. I'm changing the story and I'm crediting you, Sebastian. When I was 11, driver had a heart attack and I started driving the bus. But seriously, that's where we're coming to. So, which makes me wonder why people are so concerned with other countries' views of Canada and America when we are countries that would take someone's children away from them for preparing them to go out and live their life. 11 years old, man. It's grade 6. When I was grade 6, I was waking up at 5 in the morning and delivering newspapers all by myself in the big scary city of Vancouver. Barely. I know, right? Those newspapers were heavy. And sometimes, Adara, it rained. And look at me, I'm still okay. Barely scarred. All right. Now, wait a moment. What if I was an offensive lineman for the BC Lions and I weighed 125 kilos? Could we do that one in our heads? Why? Because 5 is the cubed root of 125. Everybody cool? What? The cubed root of 60? No. Oh, there goes the screen again. I'm not holding my breath this time. That made me dizzy.
I'll hold it.
You'll hold my breath? How could that work? My kid used to practice holding his breath because when he was young, we watched a documentary of free divers. You guys all know those free divers? You know who they are? They swim down, bottom of the ocean, no equipment. So my son was like, damn, that's cool, Dad. I'm going to practice that. So he'd go to the swimming pool and he'd practice it. And he'd freak out lifeguards. Because he'd jump off the diving board and he'd just sit on the bottom. And the lifeguards are like, what the hell? I'm like, it's cool. Don't worry about it. You would think I would know this, right? But one time, he was taking a bath. And I had to pee. And I wasn't going to wait because I knew he was in the bath. So I walk in, face down in the bath. I was, ah! And then I grabbed him and he got all mad at me. He's like, Dad, it was like a record. What's funny is it's the second time it's happened in my family because I once in a swimming pool was practicing and I told the lifeguard what I was doing, so the lifeguard wasn't worried about it, but my dad was outside the fence. Some of you have heard this story. My dad hurdled the fence like a giant gazelle and ran into the pool in all his gear. My dad was a logger at the time, so he had big work boots and like flannel and stuff. He grabs me out of the blue. It's the most embarrassing thing that's ever happened to me.
You didn't know how to swim?
No, I did know how to swim. You should pay attention to the whole story. You'll come across much more intelligent. See what I did there? Ellie's laughing because she got it. All right. Are we back connected yet? Oh, good. The story took long enough for it to connect. So, without a calculator, oh, Mr. Myers, why do you have to be that way? You're so cruel to us. I'm not. This will mix everything we have done so far. Are these the same base? So what do we do with the exponents? Add them. So what do I get? 0.03, oh, not 0.03, idiot. 0.3 squared. What's the answer? No calculators, what's the answer? As I hear tick, 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 tick. What's the answer? No, it's not 0.9. It's 0.09. Because, of course, this is 3 over 10 times 3 over 10, which is 9 over 100, which is 0.9. Right? Now, all of you should already see the shortcut. If I square a single decimal, I end up with how many decimals? How many decimal places? 2. What if I square a 2 decimals? How many decimal places am I going to end up with? 4. All right, good. What if I square 3 decimal places? That's tricky. It's in the middle. 6. Because what are we doing? You double the decimals places. All right, this looks barfy and hideous, doesn't it? Is it? No, why? Because aren't those the same base? So wouldn't it be exactly the same as x to the negative 4 squared times x to the 2 cubed? So what do I do right there? That's x to the negative 8 times, what do I do right there? X to the 6. Same base, and I'm multiplying. What do I do with the 6 and the 8? Add them together. So now I have x to the negative 2, yeah? What does a negative exponent do to its base? Reciprocates it. What's its base right now? 3 over 2. So what does that negative exponent do to 3 over 2? Oh. Oh. Starts with an R, ends with an E, has reciprocate in the middle of it. Reciprocates it. So this becomes 2 over 3 to the positive 2. Does it affect that? This is tricky. Should this be negative? Yes. Will my final answer be negative? I need a yes or a no first. Then I'll answer your question. Is my final answer negative?
No.
Why? Because negative is inside the brackets and it is squared. So the answer is positive 4/9. Now, Bea said, when I reciprocated this, why is that negative still there? Because negative bases are still allowed. This negative 3/2 is technically negative 1 times 3/2. I'm sorry? No. All right. What's different on 3? It's division, but are all the bases the same? So even though they're ugly, we know what to do, yeah? What do I do up top? 1.4 to the 7th over 1.4 to the negative 2. Now what? (1.4 to the 9th). And because I'm not letting you use a calculator, that's your final answer. Everybody cool?
Even on the test?
Even on the test. Where should I start with number 4? I should start with the denominator. What should I do? I should add the exponents. And what do I get? Which is? 6 over 3 is 3 over 2.
Why do you let me say that? 4 over 2. 3, 4, 6. 3 over 2. Is that not right? Let me from that. We need that. 3 over 1.
Swing and a miss. 2.
Times 2 on the bottom. See, I know my numbers confused.
First try, Lego Batman. First try. Now what should we do? Subtract. I need to do 7 to the 2/3 minus. Now, this is where it gets tricky. As soon as you saw 6/3, you wanted to make it 2. But now you just got to put it back to 6/3. Because you got to subtract. So that is 7 to the what? Negative 4/3, right? What does a negative exponent do to its base? Reciprocates it. So what does this 7 become? 1 over 7 to what power? 4/3. Can we leave it that way? Is that okay? Yes, that's fine. Is there more math that I know I can do with that fraction? I could go the cubed root of 1/7 all to the 4th power. Is that a right answer? Is there more math we could do? Does 1 have a cube root? Really? 1. 1 times 1 times 1. Does 1 have a cube root? Okay, so the cube root of 1 is 1. What is 1 to the 4th power? 1! 1 times 1 times 1 times 1! 1 over the cubed root of 7. And that, at the bottom, would be the 4th power. We could do even more math with that, but we're not going to, because I could fill up this whole page. You could stop there. You could stop there. You could stop there. You could write this, 1 over the cubed root of 7 to the 4th. You could write 1 over 7 cube root 7. You could write cube root, sorry. You could write, I'm not making you do it. I'm just showing you all your options. You could write the cubed root of 49 over 49. That is where you will be ending this question when we get to the end of this unit, the second unit. You'll have to be able to get to there. I know you can't wait, can you? It's like Math Eve. No? No one? Christmas, nothing? Christmas Eve, you're excited about the next day? None of you are excited to know how to turn this into this? Not even a little bit? Come on, curious. Give me curious. Thank you, Marcos. The projector literally died. Yes, the suspense killed it. It hasn't done this year or this semester. I'm a little sad. It was going so well. Oh, I don't know. My assumption is the networking. I am curious. I am very curious, but networking is the modern day equivalent of magic. Because none of us understand it. Right? A few people understand, and there's a philosopher who says, I can't remember his name, but every technology, until it is understood, is the exact same as magic. Right? Because we can't explain it. So what do humans do when we can't explain something? We say it's magic. Right? Why is there an eclipse? I don't know. God is making it dark. That's our answer. That's our answer for everything that we don't understand. Right? But not necessarily God, whatever your gods happen to be. Right? Why does the sun move across the sky? Well, it's actually Apollo, and he's got a chariot, and he's got all these horses, and he pulls the chariot, and the chariot is the sun, and he's in the back of it. Oh, really? And we all look at that and we mock it. Like, what a bunch of idiots those Greeks were. We do the same thing now. Hey, we're back. So, where does your work begin? Oh, there we are. All right. What do we do in 5? Okay, so what do we get? X to the 5th and y to the... Is that okay? Nice. What about here?
2a squared b.
Ooh. Where should that negative b go? Yeah, she did that all in one step, but she had the last step a little wrong. Where should that b go? It's already on the bottom. Well, then what's 3 plus 2? Because when you bring it to the top, it becomes positive. You knew that before a lot of other people. Stop it. 7. What are we doing right there? So what do we get? 1.5 to the 15th over 1.5 to the 5th. Now what?
So 1.5 to the 3rd.
Tricky. 2 ways to do it. What do you want to do? There's 2 ways to do number 8. Gagan, what's your way? Okay. So then you would get 8 to the 1/3, a to the 3/3, and b to the 6/3. Right? Is that okay? What's a to the 1/3? That's 2, because that is the cubed root of 8. What's 3 divided by 3? So it's a to the 1. What's 6 divided by 3? B to the 2. 2ab squared. Now you will notice how much of this you are starting to do, all of you, in your heads. I know this because I am not hearing tick, 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 on the calculators. Why? Because you're practicing more. Even though you don't feel like you're practicing, you are. What's number 9? Oh, barf. Yes, of course I can. Why is 9 so barfy? No, it's a 2. My Z's have a cross through them, as do my 7s. For that precise problem. Why is 9 so barfy? There's fractions, there's negatives. Blech. But break it down. What's 4 divided by 2? 2. Where does that negative 2 have to go? To the bottom, where there's already 2. So now how many are on the bottom? A to the 4th. What do I do with 2/3 and 1/3? Subtract. What's 2/3? Take away 1/3. 1/3. B to the 1/3. All in your head. Is that done? Is that one of the levels of doneness? Sure. What more math could you show me there that you know math? What could you do? You could say 2 cube root b over a to the 4th. Do both of those make me happy? Yes. Right? What if I asked you for exponential form? Which is correct? Red star or gray star? Oh, they'll come up in a sec. The red star is the top one. The gray star is the... Oh, there they are. Which is exponential form? The top one is all exponential form. The gray one is what we would call radical form, which we're getting into in the next unit, right? They're both the same thing. Number 10 is super hard. Especially if you try to attack it right away. What is one thing you could do first with number 10? Simplify inside. That's the way to do this one, right? Why would you deal with 125 when you know that's 4? Right? Why would you deal with 2 A's when you know that that A is going to cancel and you're going to be left with 4 on the bottom? Why would you deal with a negative exponent here when you know you could move it to the top and make it positive? And now we've got to the 1/2. What does 1/2 as an exponent mean? Square root. So I'm going to take the square root. And does that 1/2 apply to everything inside? So what is the square root of 4? 2. What does the 1/2 do with that exponent? So what is it? What's 1/2 times 1/2? 1/4. Over, what does the 1/2 do with the 4? It's 2. Why is it 2? Because half of 4 is 2. Is that okay for an answer? Yup. And, well, not better, just different. What would you do with B, this? 2 4th root B over what? A squared. Both the same, both make me just as happy. Okay? When we get to the end of the radicals unit, though, I'm going to want to see that one. Everybody cool? All right. I'm not going to make you do this yet. I want to ask you something. How many of you want to start putting -2 in for x's right now? Be honest. Thank you, Marcos. I think there are more that would want to do it. I think. Pardon me? Like what other stuff? That would be a good move. You should get more comfortable with what we've been doing. And what have we been doing, Bea? Haven't we been doing x times x with exponents? Haven't we? And what should I do with those exponents when I'm multiplying them? What is 3/2 plus 1/2? 4/2, which is 2. So isn't that really x squared? Right? So we'd write x squared. What are you going to do with the y's? So what is it? Y to the 1. So now all of a sudden, that disgusting looking expression for 11 is really just what? It's really just x squared y, isn't it? You're going to use your one out?
Yeah.
Okay. Got 4 more days, you know.
Yeah.
Okay. Oh, I lie. Only 3 more days. This is a short week.
Really?
Twice a week. Twice a week. So now how easy is this to do? You can do it in your head now, can't you? What's negative 2 squared? What's 4 times 3? Easy peasy lemon squeeze. Do it in your head, right? How many of you, like Marcos, wanted to start throwing those X's and those Y's in right away? Be honest, a lot of you. Simplify first, okay? What do you want to do there? You can talk to your neighbor. You can try to work that one out. Kids always give me the wrong answer for this one. Simplify first. Where should we start simplifying first? The inside. I like to go to the very, very middle and work my way out, right? So what would you say is the middle of this? I would say it's this part of it right here, right? Maybe just that, right? And what's the first thing that affects that? This 4, yes? Everyone agrees? Okay. So how does that simplify? What is that going to become? It's very tricky. It's going to be negative x to the 12th, or is it going to be negative x to the 12th? Which is it? Is it 1 or is it 2? It's 2, isn't it? And isn't a negative to an even exponent positive? So what's going to happen to that? It's gone, right? So this is x to the 12th, x to the 4th, all to the 3rd. What do I do there? Of course you add them. Same base we're multiplying. All that to the 3rd. What do I do with the 3rd? So it's x to the 48th, yes? I'm not going to get you to do x to the 48th because your calculator, some of your calculators won't show the right answer. But I will ask you this. Will this answer be positive or negative? Why? Because this negative will be part of the base with an even exponent. Everybody good? All right. Oh, God's going to make me cry. Don't do 13 and 14 because I don't want to review what the formulas are for those things. Nope. Okay. I think I did not supply the answers here. So let's go with on 20 and 21. Let's go with every other letter. So A, C, E, and so on. I trust you. 22. 22 can be wholly optional. But for all of you who are ever asking for extra practice, there's a whole page of it. Because it's just more exponent laws. But you can see at the bottom, they get a little snaky, right? I will show you the answers to all of them on page 22. It's 12:40. Class ends at 1. I got time. I'll come around and get your scores out of 8 personally in a moment. All right? Go.